Hey guys, this is going to be my first attempt at making a video for you guys. I hope everybody had a wonderful weekend. Oops, goodness gracious. I hope everybody had a wonderful weekend and wow, looking forward to tomorrow. I'm going to try this and see if this is going to work for us. Where's my kitty? Kitty, kitty, kitty. Why don't you come meet everybody? All right. So I've got a few notes down here. I'm going to get myself comfortable. And what we're going to be actually doing this evening is we're going to be converting repeating decimals to fractions. So I'm going to start out with 3 different repeating decimals. And I want you to notice that the first one, we have 0.2 repeating, and that only has 1 digit behind the decimal. So if I only have 1 digit that repeats, I'm going to use a multiplier of 10 because I'm going to actually move my decimal using that. Here I have 2 digits behind the decimal, so I'm going to multiply that one by 100. But also this one only has 2 repeating digits behind the decimal. So another example of something that would have 2 repeating digits behind the decimal may be 5.372 repeating, where only the 7 and the 2 are repeating. That also would require a multiple of 100. If I had 3 repeating digits, for example, I had 6.275 and all 3 of them were repeating, I would require a multiple of 1,000 here. So this would be a multiple of 100. This would be a multiple of 1,000, okay? Well, we're going to work with the first 3 problems that you see here. I think I have an eraser around here somewhere. I was going to introduce you to my puppy, but he walked away. I don't know where he went, but in the meantime, so I'm going to just work with these first 3 problems. I'm going to give you some examples, all right? But I don't think we're going to do any more beyond that. So let's just take a look at this very first problem. So I'm going to actually tell you that I'm going to give you an original statement, and the original statement is x is equal to 0.2222. Notice how I've extended it out. That makes it really easy to work with. So now, once I've done that, I know I said I have to move my decimals, so I'm going to need a multiple of 10. So if I multiply both sides by 10, that will actually move my decimal right there. It's equal to 2.222. Okay. So I have an original statement. This original statement tells me what x is equal to. And I want to use this to get rid of my decimal. Come here, Mike. Come here, meet everybody. Come, Mike. He's deaf. He cannot hear. Here, I'll bring him over here. Okay, so you can see. Okay, here, let me put my pen down. All right, so this is Micah T. Vicious. You can see he's a really vicious boy, right? Oh, he's so sweet. Okay. He's very old. He's like 15. He'll be 16 in December. So we're just very kind and gentle with him. But he is going to bark a little bit at us. I might have to get up and let him out. I don't know. But hopefully not. All right, so I have now 10x equals 0.2222. Okay, so that's where we're at right now. But because I've been given this original statement where I have x equals 0.222 repeating, I can now combine these 2 statements into one statement. And I can do that by simply subtracting, and of course this is that magical 1, my coefficient of 1 right in front of my x, and this is minus 0.222. That's going to get rid of my decimal, okay? So now what you're seeing, okay, is me combining those. I have 9x is equal to, and when I subtract this on this side, I have 2. It's very simple. So I simply divide both sides by 9, and now I have a statement that says that x is equal to, of course, 2/9, which is something you already know because we've talked about this several times, that if I had 0.666 repeating, this is equal to 6/9. If I had 0.44, this is equal to 4/9. If I had 0.7 repeating, this is equal to 7 over 9. So here it just makes perfect sense, okay? So that's problem number 1. All right, make sure you get that down. You can use the guided notes, write that all down, and then you're going to cut along the dotted lines, and I want you to glue that into your notebook, okay? So we're going to do problem number 2 now. It's very simple. It's just exactly the same procedure, but this time instead of using a multiplier of 10, we're going to use a multiplier of 100. So we're going to come right back to where we started from. I'm going to write a new original statement, and my new original statement is going to be that x is equal to 0.3636. Notice I'm drawing it out a little bit, okay? You can draw it out 4, you can draw it out 6, it doesn't really matter. But I have a multiplier now. So I'm going to multiply by both sides by 100. So here I have multiplied by 100, I get 100x. And over here what it does is it moves my decimal 2 places to the right. So I now have 36.36. What's the matter, Mike? Mike, you need to go outside? Mike, you want to go outside? Huh? Okay. All right, he's okay. All right, so I notice I have an original statement right here. There's my decimal. I'm going to subtract my original statement, and here I'm going to subtract my decimal, 0.3636, and there it is, it's gone. Okay, so on this side what I have is 99x is equal to 36. I'm done. Divide both sides by 99. And then you can see that this is divisible by 9 and this is divisible by 9. So this is telling me that x is equal to 4 over 11. Pretty simple, right? That's pretty simple. Okay, we have one more problem to go. Make sure this is in your notebook because this is part of your notes for the day, but we've got one more to do. And then when we're finished this, I want you to practice these. It's repeating decimals to fractions, and there are, let's see, there are 4 problems and 2 challenges. Well, a challenge and then a discovery. That's a sock. Goodness gracious, that goes up there. All right. So let's try this last one. And now I have 2 digits repeating. I've got the 7 and the 2 repeating behind the decimal. So we're going to start here. This is my x. My original statement is 4.7272. I think that's enough, right? So now I'm going to multiply both sides by 100. That's 100x, and that's going to move my decimal 2 places to the right. 72. And now when I subtract 1x, I'm subtracting 1x here, and on this side, of course, I have to subtract the whole statement. So the whole statement is 4.72. All right, so we're good. We're good with this. All right, so over here we have 99 is equal to, and this is obviously gone, so this is going to be 468. Okay? So, oops, wait, where's my x? There we go. All right. So now what I have is a division problem. I'm simply dividing to get rid of that 99. And my x is equal to, and I don't have a calculator with me, so I'm just simply going to do that over here. 468 divided by 99. So 99 divided by, goes into 468, a total of 4 times. If I multiply that together, I get 396. So there's 2, 16 means that's 7, okay? So I've got 72, a remainder of 72. So this is simple stuff, guys. You do not need a calculator to do this. So I've got my 4, there's my mixed number, and then I have 4 over, my remainder, which is 72 over 99, and that's definitely not in simplest form. So I'm going to divide the top by 9, divide the bottom by 9, and x is equal to 4. 72 divided by 9 is going to be 8, and 99, 8/11. So we're good. I hope that was perfectly clear. You know, sometimes I don't get things the first time around, and that's perfectly okay. You know, sometimes you have to watch things 2 or 3 times before you get them. So feel free to watch the video again if you need to. You need to complete problems 1, 2, 3, 4, 5, and 6. That needs to be turned in. Oh, what's the matter, baby? Okay, I'll be there. I'm coming. So that needs to be in your notebook, and then refer back to your agenda in Google Classroom so you can move on to the next step. All right, guys, thank you, and see you in the morning. What, Mike? What's the matter? What's the matter, honey? Yeah, okay. You want to go outside?